A Proell Governor has equal arms of length 300 mm. The upper and lower ends of the arms are pivoted to the axis of the governor. The extension arms of the lower links are each 80 mm long and parallel to the axis, where the radius of rotation of the bolts are 150 mm and 200 mm. The mass of each ball is 10 kg and the mass of the central load is 100 kg. Determine the range of speed of the governor. Right? So this is a question. Now we have to find the range of the governor. Right? Range of the speed of the governor. So we'll find the given data first. Right? So first we'll see governor has an equal arm of 300 mm. Right? So equal arms mean PF and DF are 300 mm. These two arms, upper arm and lower arm, are 300 mm. And then the extension arms are 80 mm. Right? So this extension which carries the ball is 80 mm. Okay. And mass of the ball is 10 kg and mass of the sleeve is 100 kg. Right? Or central load is 100 kg. When the radius of rotation of the bolts are 150 mm. Right? So when this radius is 150 mm, this arm is 80 mm. Okay. And 200 mm. Right? So this is the range. Right? R1 is 150 and R2 is 200. Okay. As you see, extension of the lower links are each 80 mm long and parallel to the axis when the radius of rotation of the bolts are 150 mm and 200 mm. Right? So the radiuses are now given. So from this we can find the n, right? The rotation RPM. Okay. So for the minimum speed that is 150 RPM and for the maximum it is 200 RPM. Okay. So these are the given data, right? So we'll solve it. First one, we'll draw a line which is passing through PF as an extension and a perpendicular to the axis PD, which is DM, which will meet the PFI at I. Right? So this is PF. We will extend this line. Okay. And we'll draw another perpendicular to the axis of rotation, that is DM. This is perpendicular. So we'll extend it until it meets I. Right. So this I is the instantaneous center. And we will take moments about this I. Right? First of all, let us find the minimum and maximum speed of the governor. The minimum and maximum position of the governor is shown in this figure. Right? So here minimum radius is given, maximum radius is given, so we can find the minimum and maximum speeds. Right? So minimum radius is 150 millimeter and maximum is 200 millimeter. Okay. So from this figure, we can find H1. Right? H1 is the height while the radius is R1. Right? H1 is the height while the radius is R1. Right? Okay. So when this height may change, this will also change. Right? So we'll first find H1. So H1 is equal to PG. Right? So PG is H1. Okay. So how can we find this squared? No, this squared minus this squared will give you this, right? So under root of PF squared minus FG squared will give you the height PG, right? So PF squared minus FG squared will give you the height PG, right? So PF it's given 300 millimeter, right? PF is given 300 millimeter. All right. So we need to find the PG, that is H, right? So PF squared minus FG squared. PF squared is given 300 millimeter, so whole squared, minus FG is given 150 millimeter, right? So under root of 300 squared minus 150 squared, which is equal to 260 millimeter. So H1 is 260 millimeter, so that is 0.26 meter, right? So FM, right here, this is FM, equal GD, right, equal GD, equal PG is equal to 260. Why? This arm and this arm are equal, therefore this length and this length should be equal. If this length is equal, this length and this length are equal, therefore PG, GD and FM, these all are equal, right? So that is 260 millimeter, that is 0.26 meter, right? Therefore BM, okay, so now we can find BM, right? BM, So from B to F, it's given 80 millimeter, right? F to M, now we have found 0.26 meter, right? So we can add these two, which will give you 80 plus 260, that is equal to 340 millimeter, right? This is 80, FM, not FM, BF, right? BF is 80 and FM is 260. So if we add it, we have BM, that is equal to 0.34 meter. Okay. Now we can find the N, right? N is equal to FM upon BM, right? FM, right? FM upon BM, right? BM, right? FM upon BM into M plus N, right? So according to our formula here, right? We can find the N, Fm upon Bm into small m, that is mass of ball, plus capital M by 2 into 1 plus Q upon small m into 895 upon H, right? So this is formula to find the N. So we'll apply it here, okay? So Fm plus Fm upon Bm, right? So Fm we have found 0.26, Bm we have already found 0.34, right? 0.26 upon 0.34 into small m, that is mass of the ball, that is given 10 kilogram, okay? 10 plus capital M, that is the mass of the central load, that is 100 kilogram, upon 100, sorry, upon 10 by 10, this is small m, that is mass of the ball 10, into 895, that is won't change, upon H1. H1 is this height, we have already found 0.26, right? So this N is equal to 170 RPM, right? 170 RPM. We are just applying this equation, okay? Similar way, we can apply this equation to find the N2 also, that is maximum speed, right? So for maximum speed, this length will change as 200, right? Why? According to question, at minimum speed that is 150 millimeter and at maximum it is 200 millimeter. So this length at minimum it's 150 millimeter, and when it turns as maximum it is 200 millimeter. Okay, so we can find this PG again, right? PG is equal to under root of PF squared minus FG squared, right? PG is equal to under root of PF squared minus FG squared. So under root of PF squared we know 300, right? 300 squared minus FG, that is 200, 200 squared. So when we solve it, we will have 224 millimeter, right? So PG would be equal to 224 millimeter, that is 0.224 meter. All right. So since this arm and this arm are equal, this height and this height is going to be equal. So that is PG will be equal to GD, and this GD will be equal to FM, right? So this GD, this FM, and this PG, all three will be equal in length. That would be 0.224 meter, right? So PG equal to GD equal to FM equal to 0.224 meter, right? So since FM is known, we can find the length of the BM, right? So already BF is known 80 millimeter. Now we have found FM, that is 0.224 meter. If we add these two, we will have 0.304 meter, right? 0.304 meter. All right. So now from these data, we can find the N2, right? So N2 square is equal to, according to the equation, FM upon BM, right? FM upon BM, that is 0.224 upon 0.304 into small m, that is mass of the ball 10 kilogram, plus capital M, that is central load, that is 100 kilogram, upon small m, that is 10, again mass of the ball, into 895. 895 is a constant term, upon H2. H2 is, this is the H2, we have already found it as 0.224, right? So when you solve it, we will have N2 as 180 RPM. Okay. So you may wonder, why didn't we use this alpha beta terms, right? Why didn't we use? Because this length and this length are equal, and therefore alpha is equal to beta. Therefore tan alpha upon tan beta is equal to 1, right? And therefore 1 plus tan alpha upon tan beta will be equal to 1 plus 1, 2, and that 2 and m by 2, this 2 will be cancelled out, right? I repeat. So here we have a q, right? So this q is tan beta upon tan alpha, right? In our question, alpha is equal to beta. So therefore tan alpha will be equal to tan beta, right? So if tan alpha is equal to tan beta, q will be equal to 1, right? So if I replace 1 here, right, 1 plus 1, that is 2. This 2 and this 2 will be cancelled out. So what we will be having? Small m plus capital M upon m, right? So that's why we don't have any q terms here, right? So small m plus capital M upon M. Okay. Why? Because alpha is equal to beta and therefore q is equal to 1. All right. And therefore, when we solve it, we will be having N2 as 180 RPM, right? So the question is to find the range. So we have already found when the minimum rotation speed, that is 170 RPM. Now at maximum rotation, it is 180 RPM. So the range is 180 minus 170, 10 RPM, right? 10 RPM. Okay. So this is the question, right? What's the question? Question was asked, determine the range of speed of the governor, right? So now the range of speed is found as 10 RPM. Okay. So this may also be solved by taking moments, right? How do we do that? From this figure, all right, sine alpha is equal to sine beta is equal to 150 by 300, right? Sine alpha, sine is opposite upon hypotenuse, that is 150 by 300. Right? Similarly, sine beta, that is opposite over hypotenuse. So sine alpha is equal to sine beta. How much is that? 150 upon 300. Sine beta is also 150 upon 300, right? So that's equal to 0.5, right? So we know if sine alpha is equal to 0.5, alpha would be equal to 30, right? So sine theta is equal to 0.5 means theta is equal to 30, that we know, right? So therefore alpha is equal to beta is equal to 30, right? So this angle we know that is 30, all right? So this angle is 30, this angle is 30. And MD is equal to MD, this length, right? MD is equal to this length FG, which is equal to 150, right? So this length is 150 and therefore this length is 150, right? MD is equal to FG is equal to 150. And Fm, this Fm is equal to Fd cos theta, right? That is cos beta. Fm is equal to Fd cos beta with the angle, right? So Fd we know 300, this angle we know, right? So Fd into this angle 30, which will give you 300 cos theta, that is equal to 260 millimeter, right? So Fm we have already found. And Im, right? Im, that is Fm tan alpha, right? Why? Because tan alpha is equal to Im upon Fm. Therefore, Fm is equal to, therefore Im is equal to Fm tan alpha, right? So Fm we know that is this length GD, that is PG, which is equal to 0.26 we have already found, right? 0.26 into tan 30, we know the value of tan 30. Therefore, when we resolve it, which will give you 0.15 meter. So Im is 0.15 meter. And similarly, BM, right? BM, we can add this length 0.26 plus this 80, which will give you 0.34 meter. Similarly, ID, now we have found the MD length and IM length. So when we add these two, that is 0.15 plus 0.15, that is 0.3, right? So MD is 0.15, IM is 0.15. So MD plus IM is equal to 0.15 plus 0.55, that is 0.3 meter. So in this way also we can find the lengths. So once we find the lengths, we can simply apply to the centrifugal force formula. What's the formula? F is equal to m r omega squared, right? That's equal to m, small m, that is 10 kilogram, into omega. Omega will replace it by 2 pi n by 60 because that's what asked in the question, right? I need to find the n, right? 2 pi n by 60 whole squared into r1, that is 150, right? 150. So when you solve it, you will have 0.0165 n1 squared, right? So now we have found FC, centrifugal force, in terms of n, right? In terms of n. Now we'll take moments about this point I, right? Why? Because I have an unknown term. So I need another equation to find it. So I'll take moment about this I, right? So FC into BM. FC, this force, centrifugal force, into length BM is equal to small mg, right? Small mg into length IM plus capital MG by 2 into length ID, right? Okay. So when you replace all the terms, except for the n1, we know everything else, right? So instead of FC, I will put 0.0165 n1 squared into BM, right? BM is this length. BM we have already found 0.34, okay? 0.34 equal to small m 10, small g 9.85 gravitational acceleration into IM we have already found it is 0.15 meter. Okay, 10 into 9.5 into 9.8 into 0.15 plus capital MG, capital M 100, G 9.81 by 2 into ID, right? ID length we have already found, IM plus MB, that is 0.3 meter, right? So 0.3. So when you solve it, 0.0056 N1 squared equal to 161.865, and therefore N1 squared is equal to, when you divide this 161.865 by 0.0056, you will have 28,904, and therefore N1 is equal to 170 RPM, right? Similar manner, we can find the N2 also. How we'll make this to 200 millimeter, and therefore we can find this alpha, right? Sine alpha by opposite over hypotenuse, right? So 200 upon 300. Similarly, we can find the beta also, 200 upon 300. So from that, we can find this length, right? This length, DG and PG. So if we know any of these length, we can find this length exactly similar to this, right? So this is how, this is also another method we solve this, all right? Just finding the lengths in a different method.